Let's talk about the consistency of a matrix norm and a vector norm. Given the quadratic matrices A and the vectors x, and then we can multiply the matrix A with the vector x, the result is again a vector, and then we can take the norm of this result, and then we can compare this number with the norm of the matrix and the norm of the vector and the multiplication of these two numbers. And then if always it's guaranteed, it doesn't matter which matrix A you choose, it doesn't matter which vector x you choose, always it's true that the result here, the norm of this result, is less or at most equal to the product of the norm of the matrix times the norm of the vector. And now let's have an example. For matrices we choose the row sum norm, and for vectors we choose the maximum norm, and these two are consistent, as we will see. Please give me a matrix A, whichever you want, a quadratic matrix A. Okay, maybe you give me 1, 3, 1, 5. Give me a vector x, doesn't matter which one, let's say 4, 7. And now let's check. We indicated the maximum norm with the index infinity. And what is the result here on that side? It's 4 plus 21, so it's 25. And 4 plus 35, it's 39. And what is the maximum norm? The largest entry, the absolute value, and then the largest entry, but this is 39. And then let's compare with the norm of this norm is also indicated by the infinity sign, and then we have row sum norm. Compare 4 with 6, so this number is 6, and the maximum norm here is the 7, and the product of these two is 42, and it's true that here we have a less or at most equal. So for this example it's true, and it's always true. You can prove that mathematically, but instead of proving we can ask the interesting question, is it possible to get an equal? And if you understand that, then you almost understood the proof. Okay, can you give me an example? Let's give you a hint. Don't change the matrix, but change the vector, so we get an equal. Do you have an idea? Okay, maybe you have this idea, and then what do we get? What did we do? We choose the entries to be equal, and the sign fits to this sign. In this case we have all positive numbers. Okay, so we have a 7 and 21, so we have a 28, and we have a 42, and so we have a 42. Here we have obviously again the 6, and here we have a 7, and so we have equal, and so it's true, it's always less or at most equal. And it's impossible to give an example such that this number times that number is less than here, because if we have numbers which are equal, or the absolute value is equal, and then it's impossible to get more. As I said, you can prove that, but we don't want to do so. Okay, so we have a matrix norm and a vector norm which are consistent, but in the further context we only need this combination. This will be a piece in the proof of convergence of Gauss-Seidel or Jacobi, and so we don't want to give an example for that case. We only will need this one. So that's all what I wanted to say.